Good morning, everyone. Present here, we are from Department of Computer Cybersecurity and Information Security, GM University, Dangre. Today, we are going to present our topic under the course of Computer Organization and Architecture. Our presentation title is 2-bit number addition with carry. This works under the guidance of Dr. Arun Kumar BT, Associate Professor and the head of the department CY and IY. Our team members are myself, Omshi GA, Sujan R, Bharat RM, Yashwant PS, and Yashwant L. In this presentation, we are explain how 8-bit numbers are added in microprocessor, how carry in handled, how the flag register play a role in execution. Once again, we thank respected guide and faculty members for giving this opportunity. Now shall begin this presentation.
Tarim, uh, introduction objectives explain how can a 8085 8086 like processor adds to 8-byte number stores the sum and handles carry data location first number 70h second number 71h sum output 72h carry output 73h.
The next slide explained by Yashwant L.
Hi, hello. Myself, I am Ashwin. Now I will explain the additional scenarios shown in this slide. Adding two numbers in a scenario slide. In this example, two digits meter reading are stored in a memory locations 70H and 71H. Our task is to load both values, perform the additional and store the final results in a memory location 72H. The instruction sequence used to perform this operating is straightforward. First, we use this instructions 70H which loads the first number for a memory location 70H into a accumulate. Next, instructed move B A copies the value from the accumulators into regardings B so that the accumulators become free to load the second value. Then we load LDA 71H to load a second number for a second memory into a accumulator. At this point, the accumulator holds the second number to register B hold the first number. We know perform the additional using the ADD B. This instruction adds the contents of register B to accumulate and result is stored back in a accumulator. If there is any outflow beyond the 8 byte, the carry flag will also be set. Finally, we store the sum using the STA 72H with writes the accumulator results into a memory location 70H. So overall this program loads to the two reading adds them and writing the first 8-bit sum into the traj target memory location. Next slide will be explained by Yashwant PS.
Hi, myself Ashwant, and I'm explaining about now store carry scenario in 8085 assembly. In 8-bit addition, the maximum value that can be represented in 2255. The scenario addition may generate a carry bit, and if this result of addition exit to 255, it stores the carry flag value at 73 hertz. And if the sum is within the 0 to 255 range, the range flag remains 0. Our objective in scenario is simple. We must store the store value and flag into this memory location in 73 hertz. This means that if a carry is generated, we will store the generate to 73 hertz. Let me make you explain clearly. After performing the addition, we use the instructions no carry. JNC stands for jump. If no carry is there, uh, program will jump to label no carry, and if carry is present in the jump field, execution continues to the next instruction. This moves the value 0 1 odds into the accumulator representing carry. We store the value memory using CTA 73 hertz. After storing we use JMP hints to skip the no carry section of the code. Now in the no carry section we load into the accumulator using, because no carry was generated finally, we again store the accumulator value in 73 hertz using STA, and completing the operations. Thank you.
Myself, Sujan, explaining about sequence diagram. This diagram shows the step-by-step processing of performance 8-bit addition using the 8085 or 8086 accumulator. Steps: start. First step, start. Second step, load value from memory address 72H 70H into the accumulate A register. This is the step operand. Third step, moving A to B. The value in accumulate is copied into register B. Load value from memory address 71H into accumulator again. This is the second operand. Fifth step, perform adding B. The second operand in A is added to the first operand in B. Step 6, store the sum at memory address 72H. The 8-bit result is written into memory. Seventh step, check the carry fly. If carry fly is equal to 1, store 1H at memory address 73H. If carry equal to 0, store 0H at memory address 73H. Ended. Next side, explained by Vamshi.
Uh, Memory operation. Now I will to explain memory operation uses the accumulator and the flag register during the 8-bit addition. First, let look out the accumulator uses. The accumulator known as the A register is main register used to load the operands for arithmetic and logic operate. Wherever we perform, we add instructions. The arithmetic execution actually happens inside the accumulator. After the addition it is completed, the accumulator stores final result it larger than 255. The extra bit will not fit accumulator, instead moves to carry flag. Now let's discuss flag register usage. The important flag affected during addition, the carry flag or CY. This flag becomes one addition result executes 255. If result is within the 8-bit range, the carry flag remains 0. Along with the carry, several also change based on the result. The 0 flag Z becomes 1 if the final result stores in the accumulator in the exactly 0. The signal flag S reflects the most significant bit result, which indicates whether the number is positive or negative. Signal representation. And auxiliary flag AC becomes 1 when the carry is generated lower level. It is from 3 bit to 4 bit. This is especially used in BCD. So overall the accumulator performs the calculation, stores 8-bit, while updates status describe the nature of the result. Now I will explain the output of our project. Here I am demonstrating the 8051 program execution inside the Kelly U version simulator. On the screen you can see the startup A51 file. 51 file, which is automatically generated by Kali computer. This file responsible for the presenting the controller. The main program starts in initialize stack internal RAM clear I data section. At the top section you can see the register window show all the internal registers at the 8051 R02 R7. The accumulator AB program which the stack pointer and the data pointer. These values change the program executes each instruction. In the this assembly view the top center, you can see the CPU instructions. The yellow highlighted indicates the current program counter. Right now the instruction executed in the startup which jumps to initialize root line. In the startup U1 execution of the code checks the I data length. If the size non-zero, it runs loop clearly in the internal RAM. You can see the instructions like move, clear, which initialize the memory locations to filling them with 0. At the top bottom you can see the memory window should show RAM window. When the these update real time in simulator clears data segment. The command window at the bottom which shows the code compiled successfully is currently running in simulated mode. Overall the this project the startup process 8051 program loading the clear internal RAM, initializing registers and preparing the microcontroller to jump the main user program. Okay, next slide will be explained by Sujanati.
Performed 8-bit addition using a accumulator. Second point, stored a sum and carry a separately for a further digital processing. Demonstrated instruction sequence and flag behavior.
Okay, thank you. We are ending this project. Overall, uh, uh, our guidance of the our HOD Arun Kumar BT. Thank you for giving this opportunity. Once again, thank you.